The reason I like pens for when we go over a review is because that way you can see what you are missing, okay? So if you make a mistake, you know, okay, this is where I made a mistake, this is the part that I need to be fixing. Otherwise, if you do it all in pencil, later on you might not know what you fixed and what you knew on your own, okay? The other thing that I want to say about while we go over this review is that if you already have something not completed, do not take time while I'm going over them to just scribble everything down, okay? My answer key already posted on Google Classroom. The answers are already there, okay? It posts at 2 o'clock usually on the day of a review. So it just posted, and you can go back and look at the answers. The best way to study for a math test is for you to actually try the problem and then to check your answer. So there is no point for you to just make sure you're copying down exactly what I have, because usually you're not even paying attention to what you're copying down, you're just writing it down. So instead, just watch me go over the problem, make sure you understand what I'm doing, and then later on tonight, if you have time, go back and try those other problems and then check it with the answer key on Google Classroom. Okay? So as we are going through this front page, the rules that you have at the top, guys, these are not going to be a question on the test tomorrow. Okay? The rules are more just for you to study. All right? So don't worry too much about the rules here. So on this one, let's get it to focus. There we go. On this one, I have x plus or minus a number and y plus or minus a number. I left that blank because I want you to understand that the x and the y don't have to be adding or subtracting by the same thing. Okay, it just means that if we add, we're going right on this one. If we subtract, we're going left. On this one, if we add, we're going up. If we subtract, we're going down. So like we could be going right 5 and down 3. It doesn't have to be the same thing for both of them. Okay? The next part of this is seeing what stays the same and what changes. So if you think about an object, like tomorrow while we're doing our test, if you want to think about your calculator, because that's something that you're going to have on your desk, okay? If I slide this, did the size change or stay the same? Stayed the same. Did the shape change or stay the same? Stay the same. Did the orientation is the way it is facing, the direction it is facing. Did that change or stay the same? Stay the same. So all of those are the same for translation. When you slide something, all three of those things are staying the same. On the next one, if I were you, for reflection, for flip, right next to this, guys, next to the rules, write need to know for test. These are really the only rules that you have to know off the top of your head. Okay? Translations, there's not really like a rule to remember. Like we never mentioned this throughout the chapter. This is just what you do when you're translating something. Okay? These are the rules you have to know. If it is over the x-axis, the x stays the same. The other one becomes the opposite. If it is over the y-axis, the y stays the same. The other one becomes the opposite. Okay? If we reflect something, if we flip this, so if you look, if I flip this, did the size stay the same? Did the shape stay the same?
Yeah.
Did the direction it is facing or the orientation stay the same? No, it's facing a different direction. Like I could have flipped it this way. That one was facing now a different direction. So when you think about this, it is same, same, and the orientation you can say changed or flipped. Okay. The next one is the rotations. In the rotations, I would write next to this, will be given on test. Will be given on test. If you are going to take time to study tonight, please do not spend your time on memorizing these. I will give these to you. It is great if you already know it from me talking it through and thinking it through of, if it's 90 degrees, either one, 90 degrees, we switch the order around. If it's clockwise, that's turning to the right, so the right one becomes the opposite. If it's turning counterclockwise, that's to the left, so the left one is the opposite. If it's not 90 degrees, we do not switch the order, but they both become the opposites. So if you remember all that stuff, fantastic. Otherwise, do not take your time tonight memorizing those rules. Okay? If I rotate it, if I turn this, the size, same or different? Same. Shape, same or different? Same. Orientation, it's different. It changed, it turned. Okay? For the dilation was the last lesson that we just did. This one was the one that you multiply by the scale factor. I told you yesterday that the scale factor would be K. So when you look at this one, now mine's written a little different than what I put in our notes. KX, KY is probably how you have it written down. KX, KY. This is just saying what that really means is we're taking those for each of them and multiplying it by the scale factor. Okay? If I do a dilation, okay, I want you to look at the screen and watch this picture, not think about the actual object up on my desk, but just the screen. If I do this, that's a dilation. Did the size change or stay the same? It changed. Very good. Did the shape change or stay the same? Stayed the same. Okay, it's smaller now, but it did stay the same. Okay, what about orientation, the way it's facing? Stayed the same. Very good. So when we look at this, the size is different, the shape is the same, the orientation is the same. Okay, yes?
For dilation, I put changed order stays the same.
Yeah, that's okay.
Okay.
Tomorrow on the test, it'll actually tell you what it wants wording-wise. It'll say, for these columns, write same or different. For these, it'll say, write, I think the last one is same, flipped, or turned. Okay? Now, the front side of the test tomorrow is going to have this, but it's going to be a smaller, like, more condensed version of it. And then the other half of it is going to have real-life pictures of things, and you're going to have to say what type of transformation it was. So it might have a picture where it has something here, and then something next to it that looks like this. And you'll have to say, okay, that was something that was flipped. That was a reflection. Okay, or it might have something where it has a picture and then the next picture is like this. Okay, that's a turn, that's a rotation. All right, any questions on the front page? Great, next page. On each one, we are going to go over just the ordered pairs first. Just the ordered pairs first. You really want to make sure you have these correct before we move on. Okay. So x prime is -2, -3. Y prime is 3, 0. Z prime is -1, 2. On number 12, M prime is 1, 1. N prime is 5, 4. O prime is 7, -5. P prime is 3, -4. Okay. Yes.
You don't have like the parentheses around yours if they don't put the parentheses around them. How is that points off?
They should be there. I did not make this answer key. I would have put them there. They should be there. I believe the reason why this teacher did not is because it kind of makes things crowded. Okay? So if you don't put it on there tomorrow, I'm not going to take off points, but it really should be there. Okay? Good question. Now, these, I want to remind you of the rules. Like most of you go off of the graphs, and that's totally fine to do that. But the rules are really right here that if you just have your calculator, you would be able to do these. Okay, so like my first one, my x value is 1. So we're really doing 1 minus 3. That's what it says. Do your x value minus 3. That's where I'm getting that -2. On the next one, -7, it tells me take my y value plus 4. That's where I'm getting that -3. Okay? So that's really what it's saying to do is plug each x and y value in, plug the x value and the y value in each time. I'm sorry that it keeps going in and out of focusing. Okay, that's what we're doing to get each ordered pair. The other way you can do it is with your graph. Once you have the original one graphed, my original is in blue, by the way, in all of these. The red then, so the blue is the original one, that's my pre-image. The red one is the image, or the ones we had to write the order pairs for. Okay. So otherwise, the other thing is, if you know which ones it means for left and right and up and down, you can do that. I know my x value, if I subtract, that means left. So I went 1, 2, 3 left, and then 4 up, or 4 added would be 4 up. 1, 2, 3, 4. And that's how I got to my next point. When you're doing it, remember that the image should have the primes on them. When you're looking at them, remember we said on the front side, the shape is not changing, the size is not changing. These should look identical. One is just slid over from the other one. Any questions on these? And make sure you're using a straight edge tomorrow, because I will be docking you points if it's not a straight edge, if it's not straight lines. When I go to grade these tomorrow, this is what it's going to look like. 1 point, 1 point, 1 point, 1 point for the first picture, 1 point for the second picture. So that's 5 points. That means the next one's 6 points. So sometimes you guys think you really know what you're doing and you go super, super quick. I double check myself, because if you make the same silly mistake on all of these, that could be like 4 points that you're missing right there. Okay? Any questions on 11 and 12? All right, the next one. It's reflecting over the x and the y axis. This would be one tomorrow I'd probably use my highlighter on, and I'd highlight the x-axis and highlight the y-axis so you know which one you're flipping over. And I don't know if you can tell up there, but what I did on each one of these is if it was the x-axis, I went through and I underlined my x values in each one. Those are the ones that stay the same. Over here, my y values, because my y-axis, I underlined. Those are the ones that stay the same. The other ones all become the opposite. Okay? So here, 7 stayed the same, -2 became the opposite. 4 stayed the same, -5 became the opposite. 1 stayed the same, -1 became the opposite. Okay? In 14, h prime should be 3, 4. I prime should be 1, 1. J prime should be 6, 0. K prime should be 8, 2. And then here's what the pictures would look like. And again, if I were you, I would probably highlight those axes tomorrow, the x-axis and the y-axis, so that way when you flip, you know if you would flip this way, and this is where the highlighted is, you did not flip over the highlighted line, so you did not go the correct way. Okay, it's just kind of double checking yourself. Because some of you like to look at it and just go ahead and start doing like, okay, this was 1 down, so my opposite would be 1 up. And you start doing that without thinking about which way you flipped. I saw some of you doing it this way yesterday. Instead of 1 to the right, you were thinking 1 to the left here. So make sure you know which way you are flipping it. Are there any questions on 13 or 14? Yes. 10? Do you have a question? No? Okay. All right, go ahead and flip the page. Again, if you do not have these done, don't worry about scrambling to write them down. Just look at the answer key on Google Classroom, okay? On this one, these are the ones, guys, that tomorrow I will have the rule for you at the end, okay? So make sure you know that the rule will be here at the end. Don't skip over it. Okay, read to the end of the problem. I know for some of you that's going to be the tricky part, that you have to read all the way to the end of the sentence there to find it at the very end. Okay, but that's where it'll be. Don't skip over it. Then you have to know how to apply the rule. So you got to think about, okay, if it's really usually x, y, this means I switch the order and the left one becomes the opposite. So that's what I did on these. I switched the order and the left one became the opposite. So Q prime should be 6, 7, R prime should be 7, 1, S prime should be 3, 2, and T prime should be 3, 4. Okay? Then I put a note here because every year I have somebody that goes off of these last points when they go to rotate 180 degrees. No, it says right here, rotate the original. That's going back to these points. This one, the rule is that we do not change the order, but everything becomes the opposite. So instead of positive 7, negative 6, it's negative 7, positive 6. Same thing for the rest of them. R prime is negative 1, 7. S prime is negative 2, 3. T prime is negative 4, 3. Okay. On the next one, the rule is that we switch them around, and the right one becomes the opposite. Clockwise turns to the right. So this one would be negative 6, negative 7. R prime is negative 7, negative 1. S prime is negative 3, negative 2. T prime is negative 3, negative 4. And again, when you switch the order, guys, I suggest doing that in 2 steps. So I first always switch the order, write them exactly how they look right now, but in the opposite order, switch the order, and then go back through and change the one that you need to. Okay? When I get people doing it in 1 step, that's when they tend to make mistakes. Any questions on that part? So the other thing is each part told you to graph. You had to graph the original and you had to graph each of the rotations. That means you should have 4 parts graphed. Make sure you have all 4 graphed. The blue one is the original. The red are all of the rotations that we did. The other thing with this is I would really make sure that you have all of your labels in the correct spot. Like, I don't know, pick Q. Make sure you have your Q prime, your Q prime, and your Q prime all in the correct spots, because this one tends to have people accidentally labeling wrong. Are there any questions on this problem? The one like this tomorrow for rotation will look the exact same. All 4 are going on the one graph. No questions about this? Okay, next one. Dilation. For some reason today, dilation is the one that people have all of a sudden, like, it slipped their mind. I think it's one of the easiest, but it's the one we spent the least amount of time on because it's the easiest. When you look at this scale factor, guys, scale factor of 1.5, is that one going to get bigger or smaller? Anybody? Bigger. This one, scale factor of 2/3, bigger or smaller? Smaller, very good, okay. Remember, for scale factor, you multiply. Okay, you multiply. So you're just taking each one and multiplying by the scale factor, the x and the y, not just one of them. Okay, so a prime should be 3, 3, b prime should be negative 6, 6, c prime should be 0, negative 6 on 17, w prime should be 4, 4, x prime should be 4, negative 2, y prime should be negative 2, negative 4, z prime should be negative 4, 2. Okay. And this is what it would look like then when you graph them. Remember, my blue is my original, so that's my pre-image. My red is my image. So notice we said this one would get bigger. It did get bigger. We said this one would get smaller. It did get smaller. Okay? Remember on these that if your shape looks different at all, if it looks turned at all, it is wrong. Okay? It should be the exact same shape, just a different size for dilations. A lot of times you guys were coming up to check your homework yesterday and one triangle wouldn't look exactly like the other triangle, and you're like, but they're both triangles. Yes, but they should look like the exact same triangle. If they look different at all, you messed up somewhere. Okay? If you are ready, flip it over to the back. If you have a question, let me know. Okay, on the back side, guys, we have not done problems quite like this yet, and there will be problems like this tomorrow on the back side. This talks about congruence. Who can tell me what congruent means? What does congruent mean? Bria, go ahead. They're equal. They're the same. When we're talking about these shapes in particular, what exactly are the same, guys? What exactly are the same?
Like points on it.
Okay, so if the points aren't changing, that means what's not changing? Think so. There we go. That's the word I was looking for. Shape. I was looking for the front side. So the shape will be the same and the size will be the same. Very good. So on the back, when we talk about congruent, it's the same shape and size. Same shape and size. You might want to write that in right there. Same shape and size. Congruent means same shape and size. So A says, sequence of transformations is applied to triangle ABC to create triangle A prime, B prime, C prime. Select all, multiple answers, the sequences of transformations that could be applied to triangle ABC so that triangle ABC is congruent to triangle A prime, B prime, C prime. Okay, that's equal with the squiggly means congruent. So if you look at the front, if tomorrow you're lost when you get to these, we want same shape, same size. Translation, did they have same shape and same size? Yes. So translations are fine. Reflection, same shape, same size. Yes, those are fine. Rotation, same shape, same size. Yes, those are fine. Dilation, same shape, same size. No. So the dilations are what make it not congruent. If I were you at the top of your review right here, I would put not congruent if it is a dilation. Not congruent if there is a dilation. Not congruent if there is a dilation. Which means if we want it to be congruent, we are looking for them not to have a dilation in the answer. The first one, no dilation, it's good. Next one, dilation, doesn't work. Next one, dilation, doesn't work. Next one, no dilation, it's good. Next one, no dilation, it's good. Last one, dilation, doesn't work. Okay? So it is only congruent if it does not have a dilation. Same thing on the next one. It's worded different, but it's asking for it to be congruent. So, first one, no dilation, good. Next one, no dilation, good. Next one, no dilation, nope. Fourth one, dilation, nope. Next one's good, no dilation. The last one has a dilation, so it's a nope. Okay? Only is congruent if there is no dilation. Any questions on A or B? So then the last one is worded opposite. It says which one is not congruent. So which one would be the answer on this if we want it to be not congruent? If we want it to be not congruent, Carter?
Reflection across the y-axis, dilation, we just still have to.
Yeah, if we want it to be not congruent, we want the one answer that has the dilation in it. Okay? Very good. Any questions on that?